Okay, Chapter 8, Introduction to Probability, Question 4. This time we have a 12-sided die. Has anyone seen a 12-sided die? Played Dungeons and Dragons like 30 years ago. Maybe one of those was a 12-sided, I can't remember. Anyway, if there was a 12-sided die, what would it look like? 12 sides, numbers 1 through 12. That's what we're going to have to assume. So now we want to find the probability that we get something that is not an 8. Okay. Two ways to kind of do this. Probability of not getting an 8 means we get anything but an 8. So we could just count in our mind, well, how many things are not 8? Well, if there's 12, you take the 8 out, there would be 11 things, right? 11 possible numbers that we could roll that are not an 8 out of a total of 12. So that gives us 11 twelfths. Turn it to a decimal. 11 divided by 12 is going to give us 0.917 if we round it. Multiply by 100, it becomes 91.7%. Now that was a fairly efficient way of solving this problem. There is another way to do this, though, that can become helpful when the problem becomes more complicated. When we're looking for something not to happen, another way to calculate that is to take 100%, minus the probability that it does happen. Okay. Now in this case, it's going to look like more work, but it is helpful as you progress in your study of probability. Maybe you're going to work for an insurance company as an actuary. This type of formula comes up a lot. So the probability of it not happening is a little easier to calculate than the probability of something not happening sometimes. Okay, so this gives us 1 minus, well, what's the probability of getting an 8? 1/12. And now we take 1 minus 1/12. Well, what's another way to write 1 that would be helpful here? We could write 1 as 12 over 12. That is indeed 1 in disguise. Subtract 1/12. 12 minus 1 is 11 twelfths. Hey, we got the same answer. Maybe it looks like a few more steps, but I'll tell you what, I remember studying probability in graduate school, and this is the one that would get me. Doing it this way in some problems could take 30, 40 minutes. Doing it this way took 2 or 3. On a test, which way was the best way to work it? This way. Did I do it? I'm sorry, I didn't. But that's why I didn't do as well as I could have. So again, 11 twelfths, which is also 0.917. Turn it to a decimal, 91.7%. Same answer, different methods for arriving at it depending upon how you think of the problem. That's probability for question number 4.